Good afternoon, Pythonistas. It's April 23rd, and I'm going to pick up where I left off, but do a different set of topics. Last time we were talking about the .get method of dictionary type and how we could sort of emulate it using try-except syntax. And we also talked about the identity of items in memory, whether or not they have the same numerical value. Actually, they would have to have the same numerical value. If we're dealing with integers, there's no way that you could have the same object in memory have more than one numerical value if we're talking about the integer type. Anyway, getting off key there, or getting too much into that older topic, let's start the newer topic. What I want to do is emulate a named tuple. Some people say tuple. A named tuple, I want to emulate it as a class in code. And we're going to do an atom. So we're going to talk about atomic science, some collections, imports, what do you call them? Named tuple. And to create one, we can say atom equals named tuple. Now these are going to act just like normal tuples. We're going to say like what elements we're talking about. We have control over how they represent themselves to a degree, not too much. What we have most control over is what fields they contain. In other words, we can name each of the positions. You know how a normal tuple has positions 0, 1, 2, 3, but we can only get there using numbers, integers, indexes. But with a named tuple, we're going to be able to reach into it and grab content with the dot notation using the accessor operator. So we'll do symbol, protons, neutrons, and mass. And we can also have the long name, like not just the symbol. So that's 1, 2, 3, 4, 5 things we want to put into our atom. And I do this a lot. Like I teach a class where this becomes pretty standard. But now let's go ahead and just create a single atom to show the idea. So we'll do hydrogen. Now hydrogen is going to be called an atom, and the symbol is going to be, okay, so these are going to be individual positional arguments. There's one proton. Typically, hydrogen has isotopes. As long as there's one proton, it's going to be, let's have 2 neutrons. And mass, I'm going to just do like 3 point something because it's got the 3 nucleons. That's probably too high. And we don't get into electrons or orbitals or any of that. And long name, of course, is hydrogen. So we should read up on isotopes of hydrogen. Now, hydrogen isotope is a different concept than allotrope. You remember that from our C60 discussion and the allotropes of carbon and so forth. Diamond, C60. Okay, so graphite. Carbon we could create too. That's got 12 protons, but let's just leave it at this and now now let's talk to this named tuple and then create it as a class. So over here, when I run the code on the left, I'm going to have the benefit of what I've created on the right, and I can interactively look at H and see, oh, yes, it's an atom, and that's how it represents itself. Now, how can I interact with it? I can reach into it, asking for the symbol with dot symbol. I can also reach into it with numbers, like an ordinary tuple. So that's what a named tuple is. Now, how would we do that as a class? Let's make class lowercase atom. Usually we would have uppercase for a class name, but we've already got one of those. And let's just pass in these same arguments. And I'll just give them one letter names for now. Symbol, protons, neutrons, mass, long name, because they're really just placeholders. And then inside I would create a self for each of these. I mean, they all have the same self. I'm going to poke these values into the self dictionary, self.dunderdict. That's where stuff like this gets stored once it comes in the front door. we call the class directly. We don't use any keyword new in Python, as you may be used to from other languages, and then that just triggers the constructor in a normal day. And this is a constructor that I'm writing right now. So I'm going to call this in a minute, and we're going to actually instantiate an instance of this atom. Now, the thing is we don't have yet is the ability to address using square brackets. Like over here on the right, I could use an index, a number inside of square brackets and get back data. We can't do that yet. But nevertheless, let's run it and create h equals lowercase atom. So now I'm calling it again with pretty much the same arguments. I can say p equals, but then I have to name all the rest of them too, so let's not do that. Let's put in the same data that we had before, whether it's correct or not from a chemistry point of view. We're going to do our research later on that. So, okay, how does it represent itself? That's kind of ugly. So we're going to want two things. We can't get it with numbers at all. Like I can't go h sub 0 or index 0. It's not subscriptable. So that's what we're going to fix and then end the video. So get item and set item are what we're going to need in order to change the data, but guess what? Since it's a tuple, we can't change the data. We're going to treat it as immutable, so we don't need a set item. We just need to take an integer, which we can call I, and we will simply return. Now, what's a quick, easy way to do this? There could be a tall if statement. I could turn the dictionary into, if I depend on it being an ordered dictionary, let's try something. Let's not be fancy. Let's be simple. If this is not going to be elegant, but if I equals 0, return self s. Elif I has the value of 1, return. I wasn't going to do it this way, but actually, since this is on the fly video and it's short, because I don't have very many attributes, if you're writing something very generic and you want somehow to be able to have 100 internal fields, then clearly writing an if statement that's 100 tall is not pretty. Nobody would do it. So I'm just taking the fact that it's a small thing. Now I see I'm making a mistake here, but let's just leave it at this for now. So really it's got to be long name, right? So I got to fix these and make them what they really say. Neutrons, protons. So this is a bit of an ordeal, right? This is like, I hope I'm getting paid a lot. Okay. So just kidding. All right. And so then else. And now, what if they ask for something that's not here? Let's raise an index error. Just like I think would happen over here, right? If I take my existing H and ask for item 5, oh, it's still not subscriptable at all. Duh. But wait, what is? Oh, my earlier version, my name tuple. Let's just see how it acts, right? So go back to, okay, I see what I need to do. Just run the code over here, create a name tuple called Atom over there. Oh, we already have it. And just see how it acts when I ask for element 5. Okay, index error. Yeah, tuple index out of range. Sounds good. We'll do that. And the last thing we're going to do is if the person wants to actually see this thing out loud, they want us to represent it to the screen or somewhere else, we need to return kind of a string here. And I think the string should look just like a name tuple string. And I'm going to hard code that actually. So I'm going to return, and then I'm going to put quotes around this, and I'm going to leave those fun curly braces everywhere I need to make this something I can interpolate or substitute into, right? So let's make the screen wider. I still want quotes around it if it's a string. Like let's look at a representation of H here over on the right. See, it's got little quotes around it if it's got, so I got to keep those. So boom, and mass is going to be boom, and neutrons is going to be boom. And you know what I want to do here, there's a lot of things I could do. I want to call this a template. So I'll call it TEMPL equals, and I could break it up over several lines and it would still come out as one line. Why don't I do that and show off how I can do that? Because not everyone knows that you can do what I'm doing right now. So I still want the spaces in between, and I still need to have the colons or the double quotes have to be in the right place. So you get the idea what I'm doing, right? You can do this, and as long as you have a closing thing. And now I'm going to return templ.format, and I just want to pass in the dict. And I could do that, self.dict, if I use the right names inside of here. Symbol, protons. It's kind of wordy, but definitely readable. And since this is going to be in a textbook and they're going to pay me $1,000 per line, it makes sense that I should, really maximize my productivity here, right? So show off how you can put keywords or argument names inside of the placeholders. You can do that, and then when you unpack self-dict, it's going to just place that in automatically. The IDE is warning me that I've got mistakes. Okay, I think we're done. Run everything. Let's see how it works. I'll go straight to creating a lowercase hydrogen atom, i.e. one of our new classes. Asked to represent itself, still ugly. Better rerun this again. Shouldn't be so ugly. I just fixed that. Dang, what's going on? Let's do a reset. Okay. Run it again. Not sure about those error messages. Plowing ahead nevertheless. Okay, we should have a new atom, and it should it still doesn't represent itself the way I want it to. So why is that? Why is that? Get item. Can I use get item on this? Because I feel like I'm using my old thing. Yes, I can. So get item is working. REPL is not. Why? Why? Okay, I'm going to pause this and figure it out and get back to you. Okay, guys, I figured it out. You probably saw it the whole time, right? I had a brain disconnect because it's not REPL. REPL stands for read, evaluate, print loop. And I use that terminology a lot when I refer to the console on the right here. But it has nothing to do with representing myself in Python. It doesn't catch it as an error because you can make up bogus special names that don't do anything and it won't yell at you. So I got away with compiling, but then at runtime it was all crazy from my point of view because it was not responding to REPL. So now, yeah, it looks fine, right? So things are working out. All right, so yeah, REPL stands for, there's a diagnostic where I create my mistake again in the diagnostic and I say in REPL. So that's the kind of mistake you may never make, right? So interesting that I made it. Or you might, we spell things wrong. Be aware, special names are canned. They come with Python, and you're not free to just make up special names. And if by mistake you spell it wrong, that's what might happen. So live and learn. All right, folks, that was what I meant to cover, and I covered it with some glitches. Let's leave them in. Talk to you later.